Hello there, my brilliant A-level PE students. This is James at My PE Exam. Thanks for joining me for this recording. So we're going to sort of discuss here the relationship between force and motion. And I would say the first thing to realize, just in like an intuitive level, we should understand that if we apply a force to an object, it tends to cause motion. So, you think about it. I don't need to shove anything off your desk and make a mess, but if you take a pen which is near you or a pencil, if you apply a force to it, it will move. That is the concept of motion. So we want to look at the relationships in more detail between these two ideas and see if we can apply some kind of standard thinking and rules to this. And the first way we're going to do this is we're going to look at the notion of linear motion. Linear. I hope that the idea of linear, it kind of means to you a line, or even like a straight line. That's what we mean by linear. So let's see if we can understand that a little bit better. And here's our definition. Linear motion occurs when all parts of a body, so that's the whole thing, move in a straight line or a curve, that's the point I made a moment ago, in the same direction at the same time at the same speed. So if we first of all look at an example of that, I've got here the example of a luge pair. We've got the idea here that this object, all parts of this object are moving in the same direction at the same time at the same speed. And also, albeit they're going round bends, they're moving in a straight line or a curve, right? They're going in a straight line. It's not that they're sort of going this direction, then turning and going back up the ice and spinning. No, they're going in a straight line, and part of that straight line is that they're turning the bends, okay? So that meets our sort of criteria for linear motion. Let's take another example. We've got the idea here of this shot that's about to be putted. This athlete is applying a force through the center of mass of that shot, and it's going to travel upwards and then arc back down to the earth somewhere over here. So again, the object is not going to spin, it's going to move in a straight line, or in this case a curve. And of course it's the effect of gravity which is forcing the curve, because it's forcing the shot back down to earth. So I want to come to a point here. Let me just sort of sketch out this shot on a bigger scale. Okay, it's not quite a perfect circle. If we want to make this shot move in a straight line, okay, or if we want it to leave our hand, we can apply that force through the center of mass, of the shot, and we've got a name for this. We refer to this as direct force. Okay, so a direct force is what we would say through the center of mass. Through, my pen's getting a bit sticky here, through the center of mass. Okay, so just to be clear, a direct force that travels through the center of mass actually produces linear motion. So if you want to hit something or throw something flat and straight, we apply the force through its center. So in this case, the shot putter, is applying the force up through the center of mass and out into that sort of trajectory there, when it's then exposed to the forces of gravity which produce weight of the object to bring it back down to the ground. So we've got this direct force acting through the center of mass, producing linear motion. Okay, in the luge example, it's a similar concept. And of course what they've done previously is that the athletes, when they're pulling on the ice at the top of the hill, they've both applied their hands to the side of the luge with their hands, and they've pushed backwards, propelling themselves forwards. But the net effect is that they're actually pushing through their center of mass. Which causes them to move down the hillside on the ice in a straight line. Okay, so that's linear motion. That all seems good. That all seems sensible. What then do we understand by the concept of angular motion? Angular motion. Well, let me tell you first of all, angular motion is all about turning in a circle or in a part circle. And I hope you realize straight away that any object turning in a part circle or a circle can only move either clockwise or anti-clockwise, or clockwise or counterclockwise. It's the only two possible lines of travel or directions of travel. So our definition is when all or part of a body move in a circle or part circle. Okay, circle or part circle. So let's apply this to our tennis ball here that Rafael Nadal is striking. I'm going to change the tennis ball so it's bigger and it's redder. So imagine that red, almost circular thing is the tennis ball. Well, first of all, if Nadal hits that ball through the center of mass, okay, it's going to travel flat without spinning, okay? We know that because that's a direct force causing linear motion. But what if Nadal does something different? What if he comes underneath the ball and hits the ball? Let me do that differently. And what if he hits the ball here on this path? Okay, so he hits the ball here, but avoids the center of mass. So he hits outside the center of mass. Well, the first thing I hope you realize is that the ball will spin in that direction. And of course, we give that a name. We give that a name of topspin. The ball will topspin. And by the way, Rafa Nadal, I chose him specifically because he hits incredibly heavy topspin. So he'd topspin the ball would rotate around its axis. The ball would rotate around its axis, and we would get all of that body moving in a circle. And of course, it would then propel off over the net, hopefully over there. So first of all, we need to, next point is, we need to understand that the force that is hit outside or applied outside of the center of mass is called an eccentric force. An eccentric force is a force applied outside of center of mass. Force applied outside of center of mass. So whenever an object spins or rotates, that is what we are talking about. Think also about sort of a somersaulter or a high diver, a gymnast who would lean forward and then push with their jump, applying the force outside the center of mass of the middle of their body, and they would start to spin in the air and hopefully land safely on their feet. They do that by applying this concept of an eccentric force creating a spinning, circling effect. And the last kind of motion I'd like you to think about is what we call general motion. And it's very simple, really. General motion is the concept of linear motion plus angular motion. So it is the idea of having both linear motion and angular motion being evident within a single performance. And let me tell you that almost all sporting performances have this as a feature, general motion. So let's have a look at the idea of this athlete on the screen here. Well, we can say that their torso, this bit of their body here, is moving in a straight line at a certain speed in a certain direction at a certain time. So that we could describe as linear, couldn't we? The torso is kind of moving linearly. But let's have a look at this shoulder. Or you could take the knee or the hip. Let's actually look at the hip. Here's the hip joint. Okay, this leg moves from here, and then when of course she puts that leg back, the leg's here. We can see it's moving in a part circle. Same with the arm at the shoulder. There it is. Then it moves to here. And then the arm is in this position. It's moving in a part circle. So in other words, we have both linear and angular motion. And when we get those two things together, look, linear plus angular, that equals general motion. And almost all sporting performances are actually a summary of general motion. Okay, so the only other point I'd make about general motion is this concept of angular, moving in a circle. We have to at this point acknowledge that all of our joints operate as lever systems. You know, they're basically levers, and the only thing that levers can do is move in a circle. So really all human movement is angular because it means movement at a lever of a joint. But of course it can have the effect of moving us in a straight line, which is linear, and then therefore when we combine them we get the idea of general motion. Look, I hope I haven't confused you too much with that. I think again it's one of those cases where you think some fairly complicated definitions, terms and daft little drawings by me, but in reality it's really simple. If you push through the middle of an object, try it with, put a pencil on the table in front of you. If you apply a force with your finger to the middle of the pencil, it'll roll in a straight direction, straight line. If you apply a force to either end, it'll spin in a circle. Give it a try. It works in that way. Very simple processes applied and made to look a little bit confusing. Thanks for listening.